So a lot of great stuff happened over the last 20, 30 years of software development. And not all of it was easy, right? There were some easy stuff. There was some really hard stuff, but we managed to overcome it. We have seen a lot of presentations today and yesterday, and we're just wondering, is it that simple? So I'm announcing and switching hats. This one is actually directly from New York to my presenter hat. And today we're going to go through a journey that's going to allow us to build a robust system, robust AI system that's going to last, that's going to be scalable, and is going to bring your organization to the next level. I don't actually need the hat. Okay, so today we're going to have imaginary organization. And we're going to walk through that organization journey. We're going to learn from their pitfalls. Every pitfall that they made made them smarter, made them implement certain patterns to prevent the behaviors we're going to see. But first, before we start, let's check something out. So imagine you built your LLM and everything worked. So your development, your QA, or testing, your happy paths, everything seemed fantastic until you deployed it to prod. And then we had a customer coming in asking, oh, shoot, it just disclosed us Jennifer's salary. So let's ask it one more question. What does she do? Oh, she works at HR. So imagine now you have your full HR system data exposed in this way, and customers can query your LLM and get to know all of your employees, get their SSNs maybe, get their private addresses, phone numbers, emails, you name it. It's scary, right? So, sorry? Yeah. So let's go back and let's see how we fix it. So we first go with Greenkind. It's imaginary company. It's mid-sized enterprise, and their sales team was on the forefront of latest AI happenings, right? So they were the first to adopt ChatGPT. It helped them a lot. It boosted significantly their productivity. They were able to serve more clients, and their clients were overall happier people. So win-win. After that, they started implementing simple RAG operations, right? So you don't have to copy paste things into ChatGPT, but you just go in, ask it for some data, it goes into the source of that data, pulls it out, and does something for you. This gave them even a bigger boost, and they started growing and growing. However, there were some issues. As your app scales, you're going to face different types of challenges. Some challenges come from scale, just sheer number of people using the system. Some challenges come from a variety of use cases that you're going to have. Right? It's not the same if you are just answering some frequently asked questions from your website versus handling some private data. Today's goal for me is to get everybody up to speed with the patterns that are needed to implement a secure and scalable system based on LLMs. And you're going to go out with the toolbox, with the checklist of patterns that you need to implement for that system to be resilient. So let's go with the first challenge. As they grew, as they implemented this RAG pattern, more and more data was fed to an LLM, and the LLM had access to more data like this. But unfortunately, that data was not protected, right? So LLMs were given raw access without proper security in place, and things started going sideways. So what can we do to ensure that our data does not get into the wrong hands, and that the only people who actually need to have access to some info actually do have access to that info? First thing is they should have checked terms and conditions, right? Nowadays, there are different flavors of LLMs. Dino talked about some of them and why we would want to bring them home, and run them locally. This is one of the reasons, right? But it doesn't always have to be that way. Sometimes just reading terms and conditions, reading how your provider is gonna use that data that you have is gonna help you out a lot. So you're gonna know whether your data is gonna be used to train the LLM, and you know what to expect, right? You don't want to leak sensitive data to such an LLM that's gonna share it with everybody, right? It's not gonna be just your system. It's gonna be different systems all over, right? So if you use something, share something with ChatGPT, it might share it with other customers, which is it's a bit scary, but it's not the only way you can use it, right? If you go opt-in for ChatGPT Enterprise, your data is not going to be used for LLM training. And also, if you go with Azure, there are dedicated instances. There are providers, like Dina mentioned, that are used specifically to host your infrastructure to run LLM. Next up, using security tools and policies. So often we just, in the recent days, we just give LLM data and that's it. We think it knows what to do. But often we don't know what we gave it, right? We don't know what source of data was fed to the LLM, what was all the data that was given to it for fine-tuning, for RAG purposes. And because we didn't know that, LLM is also not going to know that. So first, we need to understand where our data is, who has access to our data, and who should have access to our data, right? Like if our traditional system does not handle this properly, our LLM system is not going to handle it either. So we need to put strict access controls, and there are platform components that offer you the ability to configure to configure them in a way that's going to be that's going to ensure security of your platform. And the next one is guardrails. For now, we're just going to say that guardrails are components that ensure that that they restrict input and output from our LLMs. We're going to check out the architecture a bit later. Okay, next up. As their systems got more and more traction, the entire company started adopting it. And more customers also started adopting it. So what's the problem? There was lack of control in the company as who uses LLM, why, and when. This led to different people overspending for different reasons. And then our CFO almost got a heart attack, right? Because when you see 1 month, you have $10,000 AI bill, and then next month you have 300K, like your palms get sweaty immediately. So what could we do about this one? Right. So first up, we need to know where we are spending the money. Right. So what are our use cases? What are the pros and cons of using an LLM? Right. If you are spending on an LLM 50K, 100K, and then you get back 5K from there, you're just wasting money, right? Unless you have a longer term plan to actually fix it and to make it a bit more profitable, you're just wasting money. Next, if you have, let's say, development environment and production environment, you usually don't want your production users being there and you just cut the LLM service because you ran out of budget in production. But it is very much something that you want to do in your local development environment, because locally you do testing. So your code hasn't been tested yet. And one of the things that actually happened to Greenkind is their developers left a debugger on, and unfortunately there was some infinite loop that ate a bunch of credits, right? But they did not have any spending cap on the model, and maybe they were even using the same model for lower environments and production, which is also a bit scary, right? Because we should be applying the same principles that we have in traditional development. Technology is going to change, but principles stay the same, more or less. So we need to apply the principles and have them guide us. Next thing is the model routing. So model routing is actually something that has existed for a while now, but it is just getting commoditized. So today we are witnessing an explosion of models, right? We have at least 7, 8 active GPT models. We have models from Meta, we have models from X, we have models from DeepSeek. So at least 20, 30 mainstream models. So not all of them cost the same, and not all of them have the same capabilities. So in this case, if we gave, for example, we always use O3. It's the most capable model of all. Let's imagine this. We're spending a couple of times more. So from 4 to 10 times more per token. And also it uses a lot more tokens because it's thinking. And you are also sometimes charged for those thinking models. So instead of paying for 2 cents to get something, you're paying $2 or $10 for the same workload from O3. And maybe that's fine, right? Maybe that's completely reasonable because O3 is the only model that can handle it. But often it's not the case. Often you just give your user, if you need to format an email, right? This is something that can easily be done by smaller models. And there's the model routing is there to determine what is the most appropriate model to handle the response, right? So there are out-of-the-box components. Take that input, and they figure out of all models that you have available, what is the most suitable one to handle your task. And this can save you a lot of money. Next one is prompt efficiency. So in the first days, LLMs were not very smart, right? They were kind of intelligent, but compared to what we have now, we see that they were not that intelligent. So we started writing prompts to explain every single detail on how something must work, because it didn't know on its own. So what we usually do is we take that prompt and we just copy paste it into a newer model. But newer model might even perform better, give you a more adequate response if you just give it a plain query, plain prompt to handle. And also those old prompts tended to spend a lot of tokens because they were verbose. With newer models, they don't have to be as verbose as before. Then caching. How many of you have had caching issues in the last couple of years? Nobody. Oh, yeah. Yeah. So we often look at caching as something that was done on traditional systems, but it is possible to use it here as well, right? The techniques are slightly different, right? You might not just concatenate all words that were in a query and send them over as a cache key. But the principle is the same, right? You have something that generates a cache key, and then you have the cached response. And then cost alerts combined with granular spending limits. This is our use case that we discussed before, where you have development and production, and you don't want them to be the same. There's no reason why they should be the same, why they should have the same limits, why they should be the same entity in the end. And actually, there was a research done fairly recently, and medium to large size enterprises reported up to 30% increase in cloud cost due to AI. So it's not just our company that is struggling, but other real companies do too. Okay, so our systems, they started sending more and more and more emails to the customers. But all of a sudden, they went wild. And they sent a bizarre late night email insulting customers' intelligence. And then it woke up a bunch of sales reps who were like, well, what is happening, right? Why are we getting all these emails? And they figured out, oh, actually, it's something generated by AI. They had to apologize. Their reputation, they took a hit. And of course, they had to give customers discount for the damage. So how can we prevent this? Right? One of the ways is the guardrails we talked about. So guardrails are actually validations on the input and on the output that prevent customers from asking questions that they shouldn't. Like asking your chatbot, what's the weather like today? Or asking your chatbot, hey, could you create me a travel plan for my vacation? Right? So input validation, input guardrail is supposed to prevent that. And then output guardrail is supposed to protect us from different outputs that we can get from an LLM. Guardrails themselves, they are sometimes LLMs, depending on the implementation. They are sometimes LLMs specialized for guardrail purposes, but there are also some guardrails that are implemented as more traditional artificial intelligence systems. And you can see, right, like the flow is customer input, then everything goes to the LLM, see and then our output guardrail is just validating that and making sure that nothing weird is happening with this one. Next one is LLM monitoring and observability. So this is a no-brainer today, right? It has been a commodity with traditional systems. But with AI systems, the tooling around observability and monitoring has started improving. It was not that great for a while, but recently it got bumped up, and we're going to see some examples later. So you can understand what happened, what was user response, what was returned, what was user's request, what was returned to the user, and everything that happened in between. And then access controls, right? So if you have an LLM that is going to send out personal data, you need to ensure that they only get access to the data that they must have, right? If it's sending data to me, then, or if I'm interacting with it, it should only have access to my data, just like with traditional systems. And if you're implementing a RAG pattern, this is usually done on an API level, right? So if an LLM asks you, hey, can you give me this? And then data for Mersim, maybe, and then it's my token, right? I'm sending my token to the system, and LLM is asking for Mersim's data. Why, right? Like that might not be a valid use case. And by implementing a traditional approach to handling data access, we can prevent a lot of data leaks. And this is not, again, something that happens only to our imaginary company. There were a lot of cases where data was leaked from these systems. Like ChatGPT had a bug in 2023 where they leaked conversation details to other customers. So I was chatting with it, and then in the morning, Mersin just sees my messages and my prompts to write better code. Then I'm not sure how many of you are going to remember, but in 2014, 2015, Bing or Bing's sister was or became Nazi, right? It started spreading Nazi propaganda. This was in like usually people think it was the predecessor to the modern LLMs, but they had to shut it down because it was interacting with people on Twitter, on Reddit, and it started being Nazistic a bit. And then we have an example from Snapchat where they gave inappropriate advice to minors as to where they should hide their alcohol. Okay. Next one is an interesting one, right? So it's something that you can easily overlook, but it is important, and it can damage your reputation. So what happened to our hero company is their LLM after a certain time started giving incorrect and outdated answers. So you ask it something that happened, like what are my products? And their product list was not up to date. And more importantly, what is the price of my product? So the price has changed. But if your system, if your LLM is not reflecting that, then you have a problem, right? You're either going to give a higher price or a lower price, and then you're going to have to compensate and do wonders in accounting to fix it later. So here, how do we go about fixing it? So tailoring models with company data is something that is, I would say, a must-have in any modern business use case. So you need to have access to data in order to get some value from it. And here we have two flavors. One is RAG and one is fine-tuning. RAG can get very expensive if you're dealing with terabytes, hundreds of terabytes of data on one hand. But on the other hand, it's very convenient to use because updates are instant. So you don't need to retrain anything. So you just do the update in your data store, you do the update in your RAG API, whatever you are using for the RAG API, and you're done, right? Data is there. But on the other hand, if you're using fine tuning, it's usually used for mostly static data. And in case of data changes, you need to retrain the model. There are some approaches to continuously train the model, to train it with deltas. But it is something that takes time, right? It's not something that you can do in 10 seconds. It usually takes, for smaller models, like 10, 15 minutes, 20, if you are updating them with a very small amount of data. If you're giving them terabytes, then they might take days to update. And if you're using larger models, it's going to take even more than that. And then data needs to be fresh, right? This is something that we already mentioned, but it is key to having your systems useful. Right? Imagine tomorrow customers, you bump up the prices. Customers go in, they ask LLM what's the price. Yes, can you buy this for me? Yes, and then the LLM just gives them a lower price because it only has access to the old pricing. And the importance of keeping data up to date can be seen from Bard's example. So Google's Bard actually gave incorrect answers. And this wiped out Alphabet's 100 billion from Alphabet's value, right? In just 4 hours, 5 hours. It came back afterwards, yes, but it shows how much damage something like this can cause to a company. Okay, so now our teams, our use cases showed more variety. And everyone was maintaining their own prompts. So this is maybe good for individual use cases. But if you have a company that has 200 sales reps, it's not something that you would want to do, right? Why? Because it wastes a lot of time. So every one of those persons, they had to write a prompt when they found the bug. they had to fix it. They had to tweak it with the future use cases. If it stopped working when the model was updated, they had to fix that as well. And all of those 200 people are doing it on their own. So, and what happened to our hero company is that they started leaking parts of the prompts and part of the data because they did not have this institutionalized. So we need a systematic approach to this issue. Right? It's not something that you can that you have a guidebook. Hey, you do this, you do this, you do this. You have guidelines that are going to help you out, but it all depends on the structure of your organization, how you're actually going to go about fixing it and implementing it in your system. Usually, a wiki is just sufficient to start. Right? You just have a shared prompt, and you have a couple of dedicated maintainers of that prompt, and then everybody has access to the prompt and is able to use it. Right? Nowadays, you can also in the agents definition, if you're using agents, you can create reusable agents. You can upgrade your co-pilot with these agents, and you can get immediate value without wasting a bunch of time and risking the inconsistencies we have seen before. And there was a prompt leak. So Microsoft engineers, they were playing around, and actually Microsoft's prompt got leaked. Background prompt, of course, the assistant prompt, how we call it, or system prompt. It got leaked because they did not follow the best practices, and they did not consult the other teams. So after we reach certain scale, it's a must to institutionalize the prompt management. How many people here have used LLMs in general, right? Like a lot. So if you have been using it for last 3 months, 4 months, right? I think it's sufficient. You have seen models getting upgraded. You have seen models getting replaced with completely newer models, or minor increments. But even those minor increments can bring a lot of issues, right? If our systems, if our prompts are made to handle things in a different way, or if we're expecting output in a certain way, even a slight change might disturb that. So this is actually what happened here, right? So with the updates, our outputs got less and less accurate because we were not planning to transition to the new model. We were kind of forced into it. And this is not something where we want to be, right? Like being forced into something, then we are in a rush and we're going to make mistakes, right? LLM is not going to make a mistake because it's doing what it was designed to do. But we are going to make a mistake. We're not going to handle the change properly. And then stuff like this is going to happen. So to prevent this, we need to evaluate the models constantly. So Microsoft doesn't remove a version all of a sudden, right? It is something that you get notified once, get notified twice. You have Microsoft News that tell you about deprecations, and if you know what models you're using, it's easy to track what's going to get deprecated in 6 months, and it gives you a lot of time to transition to the new model, to take a new model, to test it properly, evaluate it against your use cases, because your model or the newer model might be 10 times better for certain use cases. But for some other use cases, it might not. Right? Like the best example recently is movement from 4.0 to 4.5, where 4.5 shows a bit more emotional intelligence, but it produces worse results if you need something tangible, right? If you need something concrete, right? But if you need to do music, if you need to be witty with your marketing materials, then it works wonders. But on the other side, if you were using it as a part of your enterprise pipeline to give answers to your customers, maybe the tone that changed from one version to the other might not suit your needs. And then once we evaluate it, we should keep this in model registry. So again, model registry can be just a wiki page that we put out and make it available to everyone. So everyone knows what are the pros and cons of everything, of all of these models on our concrete use cases. There are some benchmarks that tell us, hey, this model is good with this model is good with this. But until you test it with your own data, you don't know how it's going to perform. And I'm sure you have seen this. Like I think we discussed it in our last summit, and that is that some models like GPT-4, first version was awesome. It was so much better than 3.5, and then over time it became slower, and also it was lazy. It was just like it was way too much effort we needed to put into it to make it do what we needed to do. So changes like this do happen in real life, right? It's gonna happen. It's gonna happen to you as well, and this is the way how you prevent it, right? Like by constantly evaluating the models and tweaking them. Next up, our AI system is down. So after a while, our company started relying fully on AI. So certain user journeys were just dedicated for AI purposes. And then our provider, our OpenAI instance went down. So we stopped receiving money. We stopped serving our customers. We got a lot of support calls. This costs a lot of money and it ruins your reputation. So what do? Just like with any system, we need to have business continuity procedures and disaster recovery for AI, right? Just like you would have one instance of your server running or servers, some instances running in East US region, for example, some others in West US. And if one region goes down, you have the other one. You need to have the same thing for your AI, right? So you should not fully, with any software system, whether it's traditional or AI, you should not always rely on it being there always. It's good if it's there, yes. And it does cost a lot of money. But that money that you invest, that 100K that you invest, can easily cost you billions in just for just a couple of hours of outages. Then next, failover routing. So we have this, we talked about routing before. So you determine what the bad model is, and then you route it there. But what you can also do is, let's say you have a locally run LLM. So you want to do an upgrade of the system. During that upgrade, the system is going to be down, but you cannot be losing millions because your system is down every couple of months for an hour, for example, for an upgrade. So what do you want? What are you gonna do? Right? You can even spin up a new site, or maybe you can go into cloud, and for that small period of time, you can use cloud services, cloud providers, to use um, them if it suits your needs, of course. If what Dino was talking about, um, and then you don't have an issue. Failover tries one model, it doesn't work, not available. Just great, goes ahead with the second one. And if the second one works, the customer is not going to notice. Maybe a bit latency, a couple of milliseconds or tens of milliseconds, but their experience is not going to be significantly degraded and they're not going to be denied of service. And then caching. So if you have systems that frequently get the same or similar types of questions, caching these might reduce the impact on the customer. So if you cache something for, I don't know, 12 hours, 24 hours, for those most frequently asked questions, you are going to have a grace period in which you are allowed, or your LLM dependency is allowed to recover. And as an example, OpenAI had a major outage in December last year, and all of their customers were down. So if you were relying on OpenAI to provide as a single source of LLM, then the only thing that you could do is just wait for OpenAI to fix it, right? But if you diversify and you have multiple LLMs running, or maybe you had an OpenAI and an Azure OpenAI instance running at the same time, you could have prevented this. And the next one, a really important topic, is how do we improve our AI? So usually, if you get an answer from an AI, you type in something, you get an answer. Oh, I'm not happy with the answer. So you type in something to clarify, then again, then again, then again, then again. And if it's not working, you just say, oh, I'm just going to write it on my own, right? But, and this is what our sales reps did. So what's the issue with that approach? You're always going to be stumbling upon that issue, right? If you are not improving. So here, in OpenAI, and what we should have in our systems as well, is some sort of feedback to the customer or from the customer. So customer can tell us if they are satisfied with the response or not, and maybe even give us a reason and what they expected. This is going to give us a lot of info to tweak our AI systems. And like that's usually either done manually, or if you fully trust the source of feedback, you can incorporate a feedback loop that is automatic, and it just goes in and retrains the model based on the data, on the feedback data that was provided. And this is crucial to having polished experience for our customers. And yeah, there was an example, a failed story from a lawyer in the US that just took a response from ChatGPT, and he handed it over to the court, and they were like, okay, this is not real law, right? Like you just made this up. And then it turned out that he did actually, he complained that this was ChatGPT, but of course they didn't help him at the end. So now we have went through a set of most important, I would say, patterns to have a successful LLM deployment. But now let's see how we go about implementing this. I actually started this demo a while ago, month, something a bit more, and I almost had it done. So I was like, okay, I need to have this, I need to have this, I need to have this. And then 15 days ago, Microsoft on their build released a bunch of things in preview, and they were like, my pattern is just a title, a menu item on their website. Another one, again, a title on their website. So there's more and more tooling um, that's going to make us more confident that our LLM, that we got our LLM implementation just right. So let's jump into the demo. So first, we're going to see some data, right? We have done some fine tuning, but let's first jump into this individual salaries data source. This can be your database. It can be whatever you want. But here, I created, or ChatGPT actually created something for me, where they put your name, role, state, and then what's your address and what's your hourly equivalent. So this is what was fed to the first model that we saw. And this is problematic. We're going to come back to this a bit later. Then there are some generic documents like pricing policy. This is something that should be, let's say, confidential, maybe. Just overview of their products, what they have, what are their prices, and then what are the commonly used items with it. Then there's some data around salaries in the US. And then these are all used as data sources, right, for RAG. However, if we want to do fine tuning, the prompt or the data that you give it is in a bit different format. So you need to give it a question that a customer would ask. And then what do you see as an answer to that question, right? So here, what is the average salary for a web developer in the United States in 2024? And then you give it a response, right? So it's a bit different. So here, you specify question and answer, and then it can derive and understand a bit of context, and it can understand if you ask the question in a different way, right? You don't have to ask the same question that you saw here. While the RAG approach, the approach that we have seen with the other data sources is slightly different. And it just gives you the data and the LLM reasons about that data. Now we're going to go into Azure AI Foundry. And first, we're going to see what we did, right? So first, so we asked it what's Jennifer's salary, and it didn't give us a response. Why? Because this is a customer chatbot, and there's no reason why the model deployed for a customer chatbot should know employee salaries, right? So you need to separate you need to separate those two. So let's now ask some valid questions. Actually, let's ask this. Right? Still, it doesn't give us an answer. Why? Because it was not designed to do that, right? Like we designed it to answer questions on our products. We designed it to answer questions on our pricing. We did not design it to answer random trivia. So now let's go with a valid question. let me actually ask a different question. Um, oh, let's see. Let's see what happens. Uh-oh. It's very secure. It doesn't let us. It doesn't let us do anything. Um, okay. Um, so here, it gave us the list of products that it has. Um, the some of them. So let's ask a specific question regarding this backpack. And this actually did happen to me before. This is why I refreshed the page, because the token here expires quickly. So it started just giving me this response all the time. Um, yep. So yeah, we got the MSRP for this one, and then we can probably, if we offered it a bit more data, we could have given it some additional, like, do we offer discounts? What sorts of discounts do you offer, and so on. So let's see how we accomplish this. So we already saw our data. So let's see how we fine-tuned the data, right? Um, oh, no, it's stuck. Sorry, I don't see my mouse pointer. See if this, oh yeah, this helped. Apologies for the slow connection. Okay, so this tab is that doesn't like it's that doesn't look like it's opening. Um, so how we go about fine tuning it? With Azure AI Foundry, it's quite simple actually. So you just choose the base model, um, which we cannot do now, and then you give it the data, right? So the fine tuning data, the questions and answers we had, you give it that data. And that's it. It does everything else for you. It retrains the model on the data that you have given it. So let me just stop the presentation and see. It's going to help. Oh, it seems like it's a bit better now. And again, fine-tuning is a problem. Okay, let's try to skip to the second thing that I wanted to show you. And that is tracing and monitoring. So this was very interesting to me. There were some solutions before that handled this, but the visualization of this one and everything looks pretty great. So this is one of the questions. So here you can track your entire conversations, and you can reason like you would have usually in a traditional sense. You would need to have some logging, and then you would have some correlation that you would use for that logging. Here it's mostly you get the behavior out of the box, right? So you deploy a model, you call it, you need to configure instrumentation on it, and then you can just see what was the message from the user, what was the response. Here you can see what are the other calls that were made, and then in the output um, you can actually see what it gave you as an output. If we had a system prompt, it would give you a system prompt as well. So a pretty powerful tool to debug and understand why an LLM gave an answer it did. Um, okay, so now we're gonna skip just briefly to monitoring, and we're gonna check our resource usage. Right. So we see here, this is relatively new instance that was spun up. And here we can see that total 98 requests were made, what's the token count, and then you can correlate this with the cost that you're going to have. And you also have cost in a different place. And you can use this to project your capacity, right, to understand how much you're going to spend in the long term. Um, one of the more important things here are guardrails. So we're just gonna. So first, oh, this is so slow. Um, Guardrails, as we mentioned, they're input filters and output filters. They control what comes into the system and what goes out to the user. Here we have something called block lists, where you can either tell it a list of words that you want blocked. So actually blocked word Voldemort here, but it doesn't seem to open, so I'm not going to be able to show you. But I would like to show you the content filters if they open. Um, why? Sorry, I would need to. Sorry? Yeah, it stopped working. They don't seem to be 24/7 as they are marketed. Um, so let's try this once more. Um, okay, let's see if this is going to open. Let's continue with the presentation, and then we can come back to this one a bit later. Um, But what you need to remember for guardrails, very important, specialized models that handle your inputs and outputs. And there are different settings that you can tweak. And they also depend on the platform itself, right? Some platforms, they just offer you like filtering out hate speech or profanity, while some others give you strict environment where you can tell them, hey, I want this enabled, I want this disabled, and you can specify it in natural language. Okay, so now we know a lot of patterns that are going to enable us to have a robust deployment. However, there is a missing piece that currently prevents LLMs from being used in medical institutions, for example, for um, patient treatment unsupervised, right? And that is explainability. So this is area of research at the moment in the industry. Anthropic is leading this, but there is no way at the moment for the LL to understand why LLM gave a certain response, right? If you ask it, why did you give me this response? It's not going to tell you the truth. It's going to go usually the other way around. It's going to tell you what you want to know, right? or what you are expecting. But it might not tell you the real reason, right? And recent research from Anthropic showed that once they gave the LLM a mission, the LLM would do everything to have that mission successful, right? It would like if you have a strategy, you give it a strategy, and then it does anything it has to do to fulfill that strategy, even if that means breaking some lower like tactical and operational, like lying to you, and it is a bit scary, but I'm sure in couple of months or year, we're going to have answer to this question as well. Um, so we went from wild, everyone doing their own thing, to actually having something institutionalized, right? To having our LLMs in the organization used in the right way. We implemented a set of patterns to prevent different sorts of behaviors that we have seen, right? These look like horror stories, but they can be prevented, right? Like you are going, you're watching a movie, and you know what's going to happen next, right? And if you know what's going to happen next, you have a way, you have a chance to prevent it. Um, so just being accurate, giving accurate responses, it's not enough for operational excellence. We need robust design of our systems to actually make them scale and make them behave as they should. And if we check all the check marks, we are going to be one step closer or very close to implementing it fully as it should be. But these are the things that are probably going to change, right? Like we had issues with deployments 20 years ago. We deployed things manually. As we saw yesterday, no longer the case. These things are going to change. It's important to stay current and to have checklists like this, and then maintain it with additional stuff that pops up, and probably remove some of the stuff that's going to go away as these things get more operationalized by the vendors. Thank you.